Welcome as always. In this video we are going to have a look at the basics of soldering. So if you're new to soldering or you've had a go and you run into issues, hopefully you will find this video useful. So in this video we're going to cover the basic tools that you need, from the iron to the choice of tip to the flux to the solder, how that all comes together and how it works. And then we're going to look at some of the more basic jobs in soldering, like joining two wires together. And then we're going to have a go at putting together a little project, soldering together a few components. So with that all said, let's jump in. Whether you are starting out in soldering or a seasoned tinkerer, PCBWay have something to offer you. With literally thousands of projects to inspire you, there is sure to be something there. With PCBs starting from as little as $5, the quality, as you can see, is truly excellent. But they don't just offer PCBs, oh no. They also offer CNC machining, sheet metal fabrication, and if, like me, you don't own a 3D printer, then they also do 3D printing. So don't forget to check them out. There is a link in the description. Thank you to PCBWay for sponsoring this video. Somewhere clean and safe to work. A silicone mat like this is ideal. Next thing is eye protection. I wear glasses, but if you don't, get yourself some safety glasses. Another thing that's really useful is some magnifying glasses like these, for especially when you get on to doing some really small close-up work. Some basic tools will come in handy as well, like some wire strippers, a little pair of flush cutters, a little pair of pliers, a little cleaning brush, anti-static, and some isopropyl alcohol, which will help clear the flux off the board, which we'll come to later. Another really useful bit of equipment is a multimeter like this with a diode test function. So beeps away, so when you're testing out your components where you've been soldering, you can make sure that you've not managed to bridge any of them and you've got good contact. Next thing you're going to want, of course, is a soldering iron, and this is one of my go-to irons. Simple on-off switch on the back and a temperature dial on the front. Really simple, straightforward little iron. And I'll talk a bit more about that in a little while, because I also like to use this iron as well. Now, this is another soldering station that I use. It's a Hewitt 968 DA+3, for those of you who want to know. And it's still the basic setup as the other one, but with a few added features. This one, we've still got the soldering iron, and that little nozzle there is a duct for pulling the smoke away, so you're not having to breathe it all the time. And over there, we've got a hot air gun, which is something that will become more useful as you become more proficient at soldering and move on to doing things like surface mount work. But in this video we're just going to be looking at through hole type stuff, the more basic stuff. So here we've got both irons side by side. This is the one from the big unit with the smoke extraction tube, and this is the one from the tiny little unit that I showed you first. Now, physically looking at them, they're both of a similar size and similar weight, really, give or take. But whilst they're still both soldering irons, they do operate in a slightly different way, and it's worth spending some time just showing you that. Before we start looking at the different sized and shaped tips, what is important is to understand some of the fundamental differences, because this is something you need to consider when choosing your soldering iron. This is a soldering iron tip for this iron here, and this one is for that iron there, and the difference between the two is obvious. And to understand that, why that is, let's take this one apart. Obviously I'm doing this while it's cold, otherwise my fingers would now be burnt to smithereens. But this will just slide off, and you will see underneath this what would be originally be white, but it's become discoloured over time. This is the heating element, and this is what transfers heat into the soldering iron tip. So if you needed to change tips, you would swap that out and pop that all back together as so. And then you're good to go again. Now with this one, just move that out of the way. If we undo this, take that apart. Now, there is no heating element inside the iron itself. The heating element is inside the soldering iron tip, which is why it's much larger. Now, there are some significant advantages to having it like this, as opposed to the ones where the element is separate. The first one is transfer of heat. Now, for that heat to go from, let me open it up again, from that heat to go from the element to the tip, there's obviously a little bit of an air gap. And I've tried to negate that and increase the heat transfer by just putting a little metal shim inside there. So I get a much nicer, snugger fit. So when that goes on, it's much less wobble than without it. And therefore, the contact between the tip and the heating element is much improved. But with these, of course, you don't need to worry about it. It's much more efficient. And as a result of that, this tip will heat up in a matter of seconds. And this tip will probably take somewhere in the region of a minute or two to heat up. I'm going to say probably closer to a couple of minutes before this temperature, the temperature of the iron is at the temperature you've set. Whereas that one is literally a few seconds. So if you're in the market looking for an iron and the heating up time you think might be an issue, then these are the ones you probably got to look at. There are different ones to this, but this is a T12 setup. But like I said, there are different ones out there. But that's something to consider when choosing your iron. It's also worth mentioning as well that these tips are indeed, as you would expect, more expensive than those. So a consideration when you are making your choices. Now, in terms of energy usage, I think both these irons are there or thereabouts 70 watts. Now, what that means is you've got 70 watts of energy being supplied to the heating element, and obviously that gets transferred into the tip. Now, you can get irons that are less powerful, you can get irons that are more powerful, but for me, 70 watts is a good medium. It will do the vast majority of the things that you need to solder. If you're doing large components, large wires, then you may find that these don't have quite the thermal mass to be able to get that energy in. There's not enough energy going into the tip to maintain it. And just as an example here, I've got a PCB under the microscope, and this larger area here, which is coloured red, a different coloured red, a brighter red, this is what's called a ground plane. And underneath all this colouring is a big sheet of copper. And so what happens is when you touch your iron to heat up one of these joints, some of that will get dissipated away. So if we are looking at one of these, you can see how it's connected to the ground plane there, whereas these aren't. What you may find is when you're trying to solder connections into here, or that one's also connected to the ground plane, is you may struggle to get enough heat into it to actually solder the joint. What will happen is the heat will quickly dissipate into the rest of the board instead of staying with the component and the wire that you're trying to solder. And what I do to try and circumnavigate that is I will turn the iron temperature up a bit. So I've got an initial hit of more heat going quickly into the joint. And in the vast majority of circumstances, that's absolutely fine. You don't need a super powerful iron. Let's now consider the different types of soldering iron tip. And first we'll look at the different shapes available. Now, there are truly a lot of shapes out there, but I've got together what are probably the most common ones. And we'll start with the conical tips. And as you will see, it shapes off, if I put it under the microscope, if I can find it, it just slowly tapers off into a point at the end. And you can get those in different sizes, of course, as you can with any of the different shapes. We've got there, the one on the left obviously is considerably smaller than the one on the right. Now, the reason for the size differences is fairly obvious, really, and that is access. You might be working on something where a big tip just really is too big and awkward to get in with where you're working. And you're working on small components that you're soldering, and the small tip may be ideal. So the size of the tip is going to be really set by what it is that you're trying to do. And we'll come back to that in a second. But here we've got another type of tip. This is a beveled edge type tip, which has seen a fair bit of use, but you can see that it's just sort of like being chopped off at the end, and it's got a large footprint. Very good for holding a good amount of solder and getting that onto your component if you're needing the tip itself to hold a lot of solder. That is a really good stout tip to use. We'll come to that one last because that's my favourite. And then we've got a knife type tip. If we get that under the camera, you can see that it just literally looks like the edge of a knife. And this is quite a good tip for using for breaking soldering bridges and the like, but it's not something that I would really use, and that's why this one isn't used at all. My favourite tip though, and the one that I would recommend you getting started with, is this type, and this is the chisel type. And if we get that under the camera, you'll see that it sort of like slopes in from both sides, more or less to a point. And the reason I like these is because I just find them so much easier to work with. Now, what you've got to consider is what the tip is trying to do. It is trying to transfer heat from the soldering iron to the component and the board that you're soldering together. And to do that, the larger the surface area of the tip, then the better the heat will transfer across. So you might argue then, well, why not just use a really big tip like what we've got here? And if I put that under the microscope for comparison, you'll see, if I can find it, you'll see there's a huge difference in size there. Now, a large tip holds and will transfer heat so much better than what a small one will, so why not use a large one all the time? Well, A, you might not have access, and B, if we bring a board into place, if we look at just how large this tip is in comparison, if I was, say, trying to heat up that middle pin, that the second one in, if we get that under the microscope, you'll see that it's effectively joining three together. And what that might mean is if you've heated up all three, not only are you wasting heat onto the other two pins, but what you're also doing is you're risking applying, when you come to when you come to put the solder on, you might find that the solder jumps across all three and forms a bridge because all the joints are hot enough to take the solder, which isn't a good thing. When choosing the size of the tip, it really wants to be the size of the component that you are working with. And here we've got, if you look at the vias on the microscope, this one is a fraction too big. You can see it's not joining onto the joining vias. It's just slightly too big, a fraction, but more than workable. Whereas the other one is just ridiculous and far too big for this sort of job. It's just huge. So depending on what you're working on will set the size of the tip. You want to use the biggest size tip for the job that you're working on, and that will maximize the heat throughput. Too small and you will struggle to get heat into your joint. If you're working on something big with a tiny little tip, then you will really struggle to get the heat into the component. Likewise, I find with the conical tips is because it's such a fine point at the end, the point of contact is really quite small, and I just don't think they are as good. They have the place where you absolutely need the access, but for general soldering work, I personally would recommend using one of the chisel type ones. That's my recommendation if you're starting out. With time and practice, you may come to prefer a different one, but that's what I would recommend to begin with, just because you're going to have a better point of contact and a better heat transfer. Now, before we start looking at the solder and the different types of that, I really want to talk to you about Flux. Now, Flux is absolutely essential in the process of soldering. Its primary jobs are to remove the oxidation layer, which will occur on any metal exposed to the air. If the metal is oxidized, then the solder will not stick to it. So that's one of its essential jobs. And the other part, which is really quite essential, is its wetting ability. And that is, it helps the solder flow and forms good, stable electrical joints. Without Flux, you are not going to be able to solder things together. It really is as simple as that. Now, these are the two fluxes that I use. One of them is in a paste form, which is like this, which I used to use all the time, but I've since transferred to using this type of flux, which is, it's sort of like a gel form, and I find it just easier to manage. They both work really well and they both do the job, but I find these are much easier to use. Word of warning, do not use the likes of plumber's flux. That is not for electronics. That will corrode your board over time. Do not use plumber's flux. Use flux which is specifically designed for soldering. You may find better fluxes than what I use, but both these do an excellent job for me, and I will continue to use those. And later on in the video, as we start to do some soldering, we'll look at putting some of this flux into action. Right, so this is solder, and there are two main differences. There are many more besides, but typically you have got leaded and you have lead-free solder. Now, there is a big difference between the two. Obviously, one contains lead and the other doesn't. I do not like using unleaded solder. I find it much harder to work with, and you'll need to run your iron hotter. So my advice to you will be when you're starting out, start out with leaded solder. The lead doesn't come off as a vapour, you're not breathing it in, but it's something where when you've been handling it, you do want to wash your hands afterwards so you're not ingesting it over time, which obviously wouldn't be good. So my advice is stick with leaded solder, at least in the beginning until you get used to it. You will find it easier to use. Now, the other thing to consider is the diameter. It does come in different diameters. I've got a couple here. On the reel here is 0.5 millimeters and the other one is 1 millimeter. And you can see there's quite a substantial difference between the two. Now, the choice of your diameter will depend on what you are soldering. Typically, for electronics components, you probably want what I'm using, or possibly slightly bigger, depending on your preference. 0.5, 0.7 millimeters, somewhere like that. Once you start getting up to this size, it starts to become a little bit more difficult to manage when you're working on smaller components. What you will find using the larger diameter solder is you will end up putting too much solder either onto the joint or onto the tip. It's just a little bit too thick. You can use it, but I would say as a beginner, I would suggest you go for between 0.5, 0.7, somewhere in that range. So another thing to consider when choosing your solder is what it's comprised of. Now, the 40% lead, 6% tin is what I use. Or you might see ratios of 63, 37, something in the order of tin to lead. And what you also want to make sure you get is solder that's marked up as containing a rosin core. So in other words, the solder already has flux in it, which will once again assist you in making those good joints. There is no good reason really not to use rosin cored solder. It really is the stuff that you want to be using. Don't be tempted to try the stuff without and just think you can add the flux yourself. It's a mistake. You really do want to go for something like this. So my recommendation would be go with a named brand. Don't be tempted to go with the cheap stuff like what I do. I have found this to be very good actually for the price. But I would recommend going with a well-known brand like Kester. Get yourself some leaded 60-40 solder with a rosin core and you won't really go far wrong with that. Now we're very nearly ready to start soldering here, so let's turn the iron on and get that warming up. One thing that's incredibly important when you're soldering is to have a really clean iron tip. And my tip here is I've left it with solder on, and the purpose of leaving the solder on is to stop the tip oxidizing whilst it's sat not in use. So one thing that's really good to do is make sure that the tip is really nice and clean before we start doing any soldering work. If it isn't, the heat transfer will not be good and you will really struggle to solder if your tip is not clean. If we just have a look at the tip under the microscope, you will see that, if we can get it in focus, see the solder set on there. Do my best to show you. And so that's the old solder on it, and it just needs a really good clean. See it bubbling away a bit there. And to do that, my preference is a damp sponge. It doesn't want to be soaking wet, but it doesn't want to be dry either. And you've also got another alternative, which I do use time to time if things are slightly more stubborn, these metal shaving type things. But like I say, I tend to prefer a sponge. But as you'll see, it's giving it a nice clean already, is that. But we'll run it under the sponge just to see it's nice and shiny. That's got some residual solder on it, there's that. So we'll give it a good wipe down with the sponge. So that is the tip, nice and clean. If we put it under the scope, we should see that that's nice and shiny, which it is. If your tip isn't shiny, we can see we've got some residual solder still left on that side, so let's just give that another quick wipe. Let's try that again. There we go, nice clean tip. Well, there's still a little bit of solder left on, which I'm not going to worry about. You really must get that tip nice and clean, and if you've not been looking after it, then it may take a little bit more effort than that, but the tip should last you a good while if you look after it well. But it's really important to get it nice and clean before you start doing any soldering. I'll just put that back in its holder for now, keep it safe. Now, temperature wise, I solder at 340 degrees. Solder itself, melting point for the leaded solder is around 183 degrees. Now, why have I not got my soldering iron set down to 200, which is the lowest it will go? Well, quite simply, if we were to do that, then the solder would melt on the iron, but that'd be it. Once I went to put it onto an electrical component, that would suck the heat out of the iron and there wouldn't be enough heat there to melt the solder. So I use 340 degrees. If you go against my advice and you're using unleaded solder, then you will need to set it a little bit higher to compensate for that, probably around 370 or 380 degrees. And the reason why you don't just run it like super hot is the hotter the iron is, the less life you get out of your tip because it oxidizes more, and also the more stress you're putting on any component that you are soldering. So if you're soldering the little ICs that I've got here, if you put too much heat into these, they will be damaged. So whilst you can get away with using just a basic plug-in iron with no temperature control, that is fine for basic soldering. Once you start to work with more delicate electronics, you really want that temperature control so you can dial it down and keep it to a minimum. Now, some people go on the theory that running a slightly higher temperature will give you less time doing the solder joint because there's more heat there, and therefore put less stress on the component. But for me, I would choose 340, 350 degrees maximum, but each their own there. That is something that will come with practice, but I would recommend starting between 340, 350 degrees and see what works for you. Another really important thing to do before you start soldering is just put a little bit of solder onto the tip. It's called wetting the tip. And the reason why we do this is not for solder that forms part of the joint. If you see, every time I put the solder on there, you get a brief amount of smoke and then it disappears. That's the flux burning off. This solder on the tip is no good for forming the solder joint. But what it is good for is, because the solder's there, it increases the contact area of the component that you're trying to solder. So it's always a really good idea to just put a little bit of solder onto the tip, and depending on what you're working with will depend how much you want on there. But a little bit of solder onto the tip, and that is going to help the heat transfer. It's not the solder that we're putting onto the component, it's just helping in that heat transfer. When we've got the joint heated up, that's when we'll start to apply the solder that will be used in the joint. So let's look at a nice simple job joining these two wires together. I've also got some shrink tubing which shrinks with heat, and we'll put that over the joint to give us a nice insulated connection so it's not shorting on anything potentially. So we'll get our wire strippers. It's thin gauge wire, so we don't need to strip off much. And that's one done. And then that's another. And just move the bits out of the way. Just get my shrink wrap tubing, which has disappeared under there. And remember to slot that onto your wire first, because obviously it makes no difference in this case scenario. Just give those wires a twist, because I could slot it on from the other end, but in the real world, if you solder the wires together, then you're not going to be able to get the shrink wrap tubing on. So we'll give that wire a twist as well. Now, there are many different ways you can join wires together, but I keep it simple. Wires are meant to carry electrical signal. They're not meant to be super strong. There is no problem, in my opinion, with just giving these wires a bit of a twist together, and we'll solder them like that. You could lay them parallel to each other. There's all sorts of different techniques that people use, but that is more than adequate as far as I'm concerned. So let's get it into the fingers and we'll get it soldered in. So first things first, we shall put a good helping of flux onto here, which will help the solder flow into the wires. Get a nice blob on that. Now when it comes to using flux, there's no such thing as using too much. It just means you've got more to clean up afterwards potentially, but there's certainly a case of using too little. So don't be scared of being generous. So the iron's now nicely heated up. Let's just get some fresh solder on just to wet the tip, just to aid the transfer. And the way you want to do it is you want the iron on one side and the solder on the other. And then when the wire's hot enough, it will pull the solder through. You don't want to be putting the solder onto the iron and then lo and behold, the solder's nicely flowed into the wire. And just to test that, we'll take it off. There it is under the microscope. You can see the solder's flowed into that nicely. Let's just take it off. Got a nice, strong physical connection. What we'll do is we'll just fold that wire over and slide the heat shrink over the top. Make sure it's in the middle somewhere, and then we'll just apply some heat, and then that will be the job done. So 1 second while I get the hot air gun. Right, there you have it. One nicely joined wire, nice and strong. Now, if you don't have a heat gun, you could use something like a lighter, anything that's going to heat it up sufficiently to shrink it. I prefer to use a hot air gun because you don't get any of the soot from the lighter, but a lighter will certainly do the trick. or indeed you could just rub along with the iron itself, and that'd be sufficiently hot to melt it. So now it's time to learn what makes a good solder joint, and to do that we're going to put together this little project that I've got in front of me here. This is the PCB. This is what we will be fitting everything to. And if you notice, it's got lots and lots, I'll just get a little pointer, it's got lots and lots of little holes. Now, this is what we will be inserting all the little bits and pieces into and soldering them into place. Now, these are all through-hole components. As the name suggests, they will be going through a hole. So quite simply, something like that, all those little legs under there, this is a socket, a 28-pin socket, all those little legs there will go through nicely, and when we get round to it, we'll go around the other side and we'll solder all those little legs into place. The rest of the components then, it doesn't really matter what they are because we're here to learn about soldering, but that there is a little monolithic capacitor, which is, doesn't matter which way that goes round. This socket, which I've just mentioned previously, now that's got a little dimple cut out with it, and as you'll see, there's also a dimple marked on the screen. So we want to make sure when we fit it, that we fit it the correct way around. Likewise, this little chip here, it's a little logic chip, and if you can see on the camera, I'll put it under the scope. You can see it's got a little half moon cut in the end of it, and that identifies which is pin 1, because pin 1 on the logic chip will be that one there. So that's pin 1. So something like this, it's really important that you get the right way around. And from the silk screening, we also see the same dimple there. So that is something that will just end up being dropped in there. The monolithic capacitor, that is something, like I say, this one doesn't matter which way it's round. When you're fitting components, we're only going to be fitting a few here, but it's important that you do check orientation. Some components it matters, some it doesn't, but you don't want to get it the wrong way around, otherwise it won't work. This we won't be soldering in. This will be sitting inside the socket. And the reason why you might use a socket on your projects is it gives the opportunity of removing this chip at a later date. This is a programmable, this is an EEPROM, a programmable, it's a chip that you can program. And the little window on it is a feature where you can use UV light to erase the chip. But like I say, we're not really discussing the projects. This is about learning to solder. And we'll also be fitting some of these PCB pins, and they'll be going on up at the top there. But this is about soldering, not about the project itself, so I'm not going to really dwell on that. But if we have a look at these holes, these are called vias, these little holes there in the board. Now these holes go all the way through the board, these vias, and they come all the way out and come on the other side. And as you'll see there on the silk screening, there's traces underneath the colouring. This is the colouring on top is a solder mask, and it just covers and protects the traces on the board. But you'll see these little lines running around left, right and centre all over the place. These are what provide the electrical signal from one part of the board to another. So it's important that those are protected and we don't damage them in anything that we're doing. Otherwise there'll be a break in the circuit, which will probably mean that whatever it is that you're working on won't work. But if we look at these vias under the microscope, what you will see is it's not just a marking on one side and another, these holes do go all the way through, as hopefully you can see. So my little spatula there looks huge in comparison, but this is what we'll be looking to put the components through and solder. As you can see, the shiny bit goes all the way through. It's really important that we're careful with these because they are fragile and they do damage quite easily. And it's quite easily for these to become damaged, and then that continuity from one side of the board to the other is broken, and then once again we have problems. Now I think the first thing we're going to do is fit this little monolithic capacitor, which just goes in here on the PCB. Like I say, it doesn't matter which way round that goes, and it just slots in nice and easy. Now, to prevent your component dropping out, because we will be soldering on the other side of the board, we'll just give the legs a little spread. Doesn't need to be too much. It just needs to stop the component falling out. So that way, when we turn it over, it stays in and doesn't fall out. We'll just give it a little bit more, because I want this to sit nice and close to the board, which it's doing there, more or less. So that is now ready to be soldered. Now let's move over to the microscope and we can have a closer look at what we're trying to do. Now, as you can see there on the microscope, we have got a nice close-up view of the via on the board, which is what we'll be looking to solder to, and we've got the legs protruding too. We've got the two legs there. So what we are wanting to do is we are wanting to get our soldering iron and want to apply it in such a way that it heats up not just the pad itself. So if we move in, but it wants to touch the leg and the pad at the same time. So if I come in at an angle like that, I'm touching the board, I'm touching the pad, and I'm also touching the leg of the component. The problem you will have is if you only heat up the pad, so you're just touching the pad, then the heat won't go onto the leg. And so when you go to solder, the likelihood is that the solder will stick to the pad, but it won't stick to the leg, and then you'll end up with a cold solder joint. It might look like it's made contact, but the chances are when you test it, there won't be electrical contact there. So it's really important when you're heating that you heat both the leg and the pad at the same time. Now my iron's looking quite crusty there because I've not heated it up and cleaned it yet. It's got the residual solder that I've left on it just to protect the tip. So I'll be giving that a clean shortly before we put it to use. So let's start iron heating up and let's see how we get on. So I've got my iron heated up. I've got it set to 340 degrees. We'll just put a little bit of solder on the tip. We don't need much, just a little bit, which is just going to help us make contact. You see the flux burning off there, so this is no good for making the joint. We need the flux from the solder. And what we'll do as well, we don't need to because this is really good solder, but what we will do is we'll just bob a little bit of flux on the joint, just so there's plenty there. You can't use too much flux. The more you use, the merrier. It just means that the more you use, the more you've got to clean off. Slightly fiddly there with the camera in the way. Right, let's get that back under the microscope. So you can see we've got a nice blob of flux there, and that joint is now ready to be soldered. So we've got our iron tinned up. We'll move in and we'll start heating and we should see the flux start to melt then. Making sure we're touching both. And then there we go. You don't want to put too much solder on, you just want enough to cover the pad. If you put too much on, it'll turn into a big ball and it won't look particularly good. And the danger of using too much flux is it could potentially start to bridge then onto the other pads. But as you can see there, we've got no issues. What we'll do is we'll give that a bit of a clean up once we've done the other one, and we'll give it a good inspection. So same again with the second one. Let's just bob a bit of flux on it. And let's heat it up again. So remember, both on the pad and the leg itself, and then the solder should just take to it nicely, which it has done. Let's clean that up and see how it looks. So to clean up the flux, I just use a little bit of IPA. I'll put it onto a cotton bud and we'll just give that a rub and clean the majority of it off. These cotton buds are ideal because if you don't keep rotating them around, you can end up with bits of it coming away and sticking to your board, but they work okay. So there we go, we've got two nice shiny joints there, and the solder's covering the whole of the pad, which is really important. So the solder's flowed all the way around. And if we look at the other side, we've just got a little bit of solder flowing through, which is how it should be. The solder's gone all the way through the joint, which is great. So there we have it, two nicely shaped joints. You can see the solder running up the component leg. The whole of the pad's covered and it's all looking nice and shiny, which is what you should get if all's gone to plan. So there we go, this one's looking pretty good. We've got a nice covering of solder on the pad and we've just got a nice gradual incline up to the leg. If you get too much solder, it's not the end of the world. You could use something like this, which is the solder braid, and just same as applying solder to the joint, just put, top tip, just put a little bit of flux on your solder braid and then just touch it on your joint with the iron and it'll just wick away the excess solder and you can redo the joint. But when you redo the joint, don't forget to apply some more flux. It's well worth remembering as well, it's quite important that you don't wiggle everything around whilst you're doing the soldering, because if there is movement while the solder is still cooling, then that can also affect the quality of the joint as well. So keep everything still until it's cooled down. Once it's cooled down, it should be fine. And then all we've got left to do, we don't need these long legs on. So with a little flush cutter, just cut those spare bits of leg off and then you can throw those bits away. So that is the capacitor fitted. Nice and simple. So that's it, as if by magic, it's all finished and put together. The only difference with fitting some of these other components is you might want to hold it in place before you solder it with a little bit of blue tack or a bit of tape just to stop things from moving around. But that's a quick look at the underside. And hopefully you'll have found this useful and prevent you from making some of the mistakes I made when I started soldering. So thank you for watching, and hopefully I'll see you again soon. Bye for now.